Chick-fil-A in that.
Anytime.
We're kind of trying to figure out what function goes with the data they give us. So let me make up an example here. If, let's say we planted a tree outside, okay, and then when we first planted the tree, so when it was a baby, let's say it was 2 feet tall, okay? So that means on year 0, it was 2 feet tall. So X will represent our time, and Y will represent our height. After 0 years, the plant was 2 feet tall. So let's say after the first year, after 1 year growing, let's say the plant was 4 years, or no, not 4. Let's do something easier. Let's say it was 3 feet tall. And then after the second year, it was 4 feet tall. And after the 10th year, it was 12 feet tall, or whatever. So this is all the data we have on the tree. What would be a function that would represent this data? So what is happening to the X value to turn it into the Y value?
Just adds 2.
Adds 2.
Oh,
So the function would look like f of x equals x plus 2. Okay, so I know this is a really simple example, but if we said after 100 years, the tree might be dead, but after 100 years, how tall would the tree be? 102. Now, do trees grow like that? I don't think so, but maybe something close to that, I don't know. But this is just an example. And they might not use x and y, or x and f of x, I guess is what we use. They might say, instead of x for the years, what might they use?
Y.
Well, t for time, right?
Oh.
And then instead of y for the height, maybe they'll call it h of x for the height. So they might write it something like this. The height of the, sorry, not h of x, h of t. The height of the tree is dependent on the time, like how many years the tree is old. And you just do the years plus 2. That's just an example. We're not really doing word problems today, but I just wanted to give you an idea of how this works. That's about as basic as you can get. But all right, number 1. It's a lot like yesterday's actually. Graph the function, rule, and domain, make a table, and write a set of ordered pairs. We're just going to do ordered pairs for 1 and 2. So number 1 says f of x equals x minus 4. Isn't that what it says? Yes. And then they give us d. What do you guys think d stands for?
Domain.
Domain. And what did domain? What does domain mean?
X values.
X values. So we're plugging those in for the x. So if x is -2, what's the function going to equal? -6.
We have to show work.
And no. If I don't show work, you're not going to have to show work. If it's that simple, no. So I just copied the problem down, but there's no need to do that either. Copying the problem down doesn't count as showing work, by the way. It's only if you have to actually do something to solve it. Okay, if x is 0, what's the function going to equal? -4. And if x is 3, -1.
For you.
And that would be all for number 1. Why don't you guys try number 2 while I pass out the graph paper?
Oh, with the. Oh.
There are 4 graphs that we're going to do.
Oh, big education work. Was trash. People milk that game. Well, I mean.
See if I can. freshman class.
I just had a face.
I think somebody was gone, I don't remember.
Wait, this is kind of small.
Yeah, we have 4 graphs, so you're gonna have to use your space wisely. Alright, you guys get number 2? Okay, number 3 says y equals negative 3x.
That's better than the main two, but.
You only have to put the graph on the graph paper.
You
My-
don't have to write anything in the other paper? About 3, 4 other?
I'll probably just be looking at the graph. But then it says d equals negative 1, 0, 2. So this is kind of like yesterday's number 17, that problem. So I'm going to put in negative 1 for the x value. And what am I going to get for the y value?
4,
8,
0,
8,
3.
3.
I don't know what for. Oh, I don't even have a 0.
Okay,
We all just blinked.
if I plug in 0,
0, 0. Down, right?
if I plug in 2,
Negative 6.
negative 6. Alright. And then the only difference on these, we gotta actually graph them. So,
Wait, did you say we?
So- no, well, I didn't show any work, I just wrote down the points that I'm gonna graph. This is the problem that I copied down, which you don't need to do that, it's just in your book. This would be like the answers we have to graph. Okay, so I noticed that my graph goes up to 3 and down to negative 6. So you need to make your graph tall enough to do that. So if it goes up to 3, your x-axis can be kind of high, like that, and then down to negative 6. You don't have to do it like that, but
So does it all have to be in like separate graphs? Or can you
yes,
do it one?
each problem has its own graph. From here on to eternity, that's how it's going to be.
Oh my god. It's like a TV.
When you guys are graphing in heaven, that's how it's going to be.
Like they're waiting. It makes sense. It's gonna have to look
Just
like
because you said that, Katie, you'll probably be an engineer in heaven.
Oh shit.
Wait, what have I done?
Foreshadow.
Wait, what did I
Be
do?
supportive.
It's like that be mad.
All right. Negative 1, 3. I'm sure that'll be math in heaven, but you won't have to do it if you don't like it.
Yay.
Negative 1, 3.
Jesus will
What if you're like a math genius in heaven, and then you do like it?
I don't think Jesus
What
would
if
do
Jesus
this.
is like, what if Jesus is like a math whiz?
You
He's
can
like,
flex on
yo,
all the
yo, yo.
angels.
like it?
Yeah, the angel would be like, hey, look at this math problem.
Of course, like, in heaven, Jesus is apparently a math whiz. Yo, yo, yo. E equals MC squared.
Okay, 0, 0. You guys know where that goes. And then 2, negative 6 would be 2 to the right and 6 down.
Yeah.
All right. Should we connect the dots? What do you guys think?
No.
It's a no. That's correct. So you need to make sure you make room. Did you draw this already, Paxton? Make sure you make room for 4 graphs.
So, do we write the number like it is beside it, like this?
No, just like I did. Just put
Oh,
the dot.
I meant like number 3 and like that.
Yeah, kind of like that. Okay, number 5. 5's a little bit different. It says y equals 2x, or h of x equals 2x plus 1. But they don't give us a domain, so what are we supposed to do about that, you think? Make up our own. And I'm gonna, even though it's like choose your own, I'm gonna say choose mine. So just like yesterday, let's use these 5 guys, because that'll put it right in the middle on 5 and 6. All right, if I plug in negative 2, 2 times negative 2, negative 4 plus 1, plug in -1, 2 times -1, -2 plus 1. If I plug in 0, 0 plus 1 is 1. If I plug in 1, 2 times 1 plus 1 is 3. And 2 times 2 plus 1 is 5. Okay, so how big do I need to make my graph? Well, on the x-axis it goes from -2 to 2, that's pretty small. On the y-axis it's going to go from, or the h of x axis, it's going to go from -3 to 5. That's not that big. But I need to make sure it goes down at least 3 and up 5. One, 2, 3, 4, 5. Okay, -2, -3 means left 2, down 3. Right there. -1, -1, left 1, down 1. 0, 1 means left to right 0, up 1. 1, 3 means 1 to the right and 3 up. And 2, 5 means 2 to the right and 5 up. Should we connect these dots? Yes, we should. Why should we connect the dots?
Because they want to be connected.
Because we
It's
never
everything
run
in
so
between
many
those.
numbers.
Oh, it's any number.
Because the domain is unlimited, the number of points are unlimited, so it's everything.
We could have made any sort of line.
No, any point you make up is going to be on that line also. Like if you plug in 1,000,000, you're going to get like 2,000,001. 1,000,000, 2,000,001, if you, like on the top of the skyscraper over there, it would still be on the same line. So no matter what point you choose, it'll be a different point on the line, but it'll still be on the same line. So I can tell just by looking at the line if it's in the right spot or not. Yeah.
4's on the graph, right?
4 and 6 are graphs, yes. 4, they give you a domain. 6, they do not give you a domain. On 6, you could use these numbers. Maybe I should just have you use these numbers. But they're going to be fractions. Because it's like 1/3. So if you do like 2 times 1/3, that'd be like 2/3. So, which is fine. There's nothing wrong with 2/3. It would probably be easier to use like multiples of 3. But yeah, let's just use the same numbers. Okay, number 7. You guys done drawing? Number 7, we're supposed to figure out what the pattern is. They say write the rule of the function. The directions say use f of x notation to write the rule of the function. Okay, the rule means what the function does. What does the function say? So we have to figure out on 7, how are they getting from 2 to 8, or 1 to 4, or 0 to 0? So how can you turn the x value of a 2 into the y value of an 8? Or how can you turn the x of a 1 into a 4? Yeah. Well, you could say this is plus 6, right?
Yeah.
But is that plus 6? No. It's got to work on all of them. So what is the way that works on all of them? Times 4. Times 4.
0 times.
Times 4. Right? It works. If it works on all of them, that's right. So what is my answer going to look like?
It's 4.
4 times x. They're all going to have an x in there. Because we're doing something to the x value to turn into a y value. And what we're doing on this one is multiplying by 4. So there is no work to show. It's a very short answer. This is not work. This is me copying the book. So you don't have to write that down either. Okay. Number 9, -3, -5, -1, -3.
That's what it does.
No, this is just me copying the book. 2, 0. If you get confused, it's probably easier to look at the positive numbers, like 2, 0 and 3, 5. You guys see what the... I think I copied something wrong. No, I didn't. Never mind. Oh, I copied the last one now. It's 5, 3, not 3, 5. Alright. Do you guys see a pattern on this one? Subtract 2. Yeah, these are all going down 2, right?
Yeah.
So f of x equals
X minus 2.
x minus 2.
Board here.
I did not write this on the board or on RenWeb or anything, but if you guys want to try 20 for bonus, you can. It is considerably harder because it's not just multiply, it's not just add, it's both add and multiply. So that makes it quite a bit harder. I don't want to spend a lot of time like explaining 19, so we're just going to keep going. But okay, number 11. So they wrote 11 in a different form, but it's the same idea. It's -5, -15, -2, -6. So if I write it in ordered pair form, what's the pattern? Times 3, right? Times 3, times 3, all of them are times 3 if you keep looking at 11. 3 times 3 is 9, 5 times 3 is 15. So the answer is f of x equals...
Yeah. Wow. No way.
Okay,
As you would say, that's unkind.
if you're getting cocky, number 13 might knock it off because the 13's trickier. It's the hardest one that's not a bonus. So we're going 100, -98, and 50, -48. Somebody in another class did figure this out though, so you got competition, so you can outthink the 9th graders. 0, 2, that one might actually throw you off. That one's confusing. I wouldn't look at that one. 20, -18. They're all kind of the same, right? They all... I'll give you a hint. It starts like this.
What? No.
Whoa. Oh my
Oh,
god.
no.
It
That's
looks
so
like.
helpful.
Does
It
that
looks
help?
like.
Subtract 2 and 18.
Minus 98. 100 minus 98 is 2.
Is it?
Subtract 2 times
Oh,
1.
this that would work on this
No.
Subtract 2 times
one, but
negative
it
1.
wouldn't work
Yeah.
on that one.
It's
Subtract 2
neg-
times negative 1.
Huh?
No.
Subtract
You
2
multiply
times
by
negative
-1 and then you add 2.
Multiply by -1 and add 2. Would that work? What's 100 times
Oh,
negative
yeah.
1?
What would be -1?
Negative 100.
And then
Plus
add
2?
Negative 98.
Can't you
50
also-
times -1
Negative 50.
plus 2?
Negative 40.
Okay.
Can't you also subtract or multiply? Subtract 2 and then multiply by -1.
Well, that's the same
What you
thing.
did.
Yeah, but it would be harder to
I'm
write it
gonna
like
start
that.
screaming.
But yeah, that is basically the same thing. How do I write that though?
So
Say it again, Eli.
What?
Say
It's
what,
multiplied by -1 and then it would be plus 2.
times -1 plus 2. How would I write that?
-1x plus 2.
There's a very slightly easier way to
What
write
if it was
that.
negative x plus 2?
So what you said, Forrest, was this, right? Times -1.
yeah.
And if you use distributive property, guess what you get? So that would work. If you use parentheses, it would work. The slightly easier way of writing this is, you don't have to do this, but it would be that.
Wasn't that on an earlier problem? Like,
No,
oh, I thought that was only this one.
but you don't have to put a 1 in front, is my point. You just put a negative. But that's okay. 15, very close. Tell me you guys have done all the evens already. Oh no, 15, what do we do? Paint.
Negative.
Someone wrote on the answers in this book.
Oh.
Seriously?
Yeah.
Grant, you know what to do?
I only know the negative. I only know the ordered pairs.
Okay,
Like negative 2, 0.
Grant says the ordered pairs are -2, 0, -1, 1. Where's he getting this from?
Looking at the graph.
Looking at the graph.
Well,
Seriously?
well, mine has all the answers in the book.
Oh, we need to erase that then.
Wait.
Here, I've got it. Well, it's not the answers, but it definitely helps you.
Is it, well, this is not the answer, this just helps.
Yeah, it's
This is to help us find the answer.
Mine doesn't have that because mine's
That's
trash.
right.
I'm just.
Pops having old tactical things, just
Okay,
I mean, it's still there.
we could keep going, right? But do you guys see what the pattern is yet?
I thought you were just like,
Oh, yeah, right.
You can get the rest.
No.
Oh, you're adding
Adding 2. So f of x equals x plus 2.
Oh, then the next one is secret.
$17, that might confuse us also. Maybe, I don't know, maybe not.
I sound like Wally there.
All real numbers is the domain, it's not the solution. So, you guys know how we got ordered pairs on 15? Can you find any ordered pairs on 17? 0, 0? That's one of them.
No way.
Let's try to find, there's a couple more that are identifiable in the picture.
3, 1.
3, 1 has a point, you guys see it?
Yeah.
They didn't draw it, the line just goes through it.
Oh, wait.
And there's one more that you can identify.
Negative 16, negative 1.
3.
What about 16?
-3, -1.
16.
Yeah, 6, 2 would work, is that on the graph? It's kind of on the
I mean,
edge.
almost.
Almost on the graph, yeah, 6, 2 would work also. Alright, do you guys, I'll put it in. You guys see the pattern? The 0, 0 might kind of throw us off. -2 would work for that, does it work for this?
Multiply by 1/3.
-3 minus 2 is actually -5.
Multiply by 1/3.
Yeah, it's, how do you get from 6 to 2?
Multiply by
Divide by
3.
3.
Yeah, but.
Is this divide by 3?
Oh, yes, that's
Divide by 3?
Yes.
Okay, dividing by 3 is the same thing as multiplying by 1/3. If I said, if you guys were like 15, 1/3 of your age would be 5. That's the same thing as 15 divided by 3. But yeah, so there's a lot of ways. It's divided by 3 basically though. So there's a lot of ways we could write that. It's x divided by 3 with the division bar, x divided by 3 with the division symbol, or 1/3 x. The last one was the one the book chose. This is probably the one that I would expect to see if I was not helping you guys.
So, Dorito.
They're all the same. Doesn't matter which one. Okay, well, you see how the line goes through the point 0, 0? It also goes through the point at 3, 1, exactly at 3, 1.
I'm a bar.
Do you see where 3, 1 is on the graph? And you see how the line is going directly through that point? So that's how we found 3, 1. There's a lot of points that it's going through, but only a few of them are easy to identify. 3, 1, looks like it's exactly going through there. Also -3 to -1. And then forced at the end said 6, 2, which is like the very edge of the graph would be 6, 2. So it wasn't as easy as 15, but there are a few points that you can recognize. Okay, that's it.